In this Back to Basics episode, we are moving up to the roof where we're talking solar panels and how they're installed. I'm Yorick Mark, a solar consultant with over a decade's experience in the Australian solar industry. As a consultant, I get lots of reoccurring questions like, how do solar panels work and what happens if one panel is shaded? Will I have holes all through my roof as part of the solar installation? What if the front of the house is my only north face and I don't want to see panels from the street? I'm going to answer these questions and more. Let's get into it. So what is a solar panel and how does it work? In this video, we're specifically talking about photovoltaic panels or PV panels. This is different to the solar hot water systems you might have up on your roof where you've got a big tank and a panel where it just takes the heat from the sun to warm hot water. What we're doing is we're generating electricity using sunlight. And how this works is we've got a silicon wafer with one side that's slightly positive, one side that's slightly negative, and when the sunlight hit it, the electrons move from the negative side to the positive side, generating electricity. These days, all panels are monocrystalline N-type wafers. There used to be a few different types. I've actually got 10 years worth of technology difference here. So I've got an older 250 watt panel and some modern 475 to 500 watt panels behind me as well. And you might say, well, what are the differences? Well, older panels tend to be like a polycrystalline panel where you had lots of little crystals and they tended to look quite blue like these old ones here. So if you're wondering, well, why are the panels I'm getting quoted black? Monocrystalline panels tend to be black. These are also what we call N-type wafers, so these are slightly more negatively doped, but without getting a real deep dive, we'll keep it a bit more entry level here. Now, there are sort of two main categories of monocrystalline N-type panels on the market today. One which we call TOPCon, and one that is a integrated back contact. At MC Electrical, we predominantly sell TOPCon panels, which is a bit more of a mature technology, but there are also now panels where all the cables are on the back of it, which can look quite sleek, and you might get a little bit of a gain in efficiency, but the reality is most modern panels today all do basically the same thing. They all come with a 25-year warranty in Australia. They will all produce electricity. They will all last basically the same amount of time. Now, very common questions I get when we're talking about solar panels is where should I put them? First things first, we always want them to face the sun ideally. So the north-facing roof or an east-west facing roof is generally the best place in the southern hemisphere. If you're living north in the northern hemisphere, like Europe or the US, or China, you might want the panels facing south because we want them to face towards the sun. But in Australia, we want them facing north or east and west. If you put them on the east, you'll get a little bit more power early in the morning. If you put them on the west, you'll get the power a little bit later in the afternoon. And if you put them north, you'll get this really nice big spike in the middle of the day. These days, I like to put panels, or I like to recommend that we put panels either on the north and west to catch that afternoon sun, kids come home from school, air cons turn on, or east and west, so we get a bit more power early in the morning. I like that with a battery especially because if we can get a little bit of energy in the battery nice and early, it means we've got some room to play with, but we'll save that for another video. So let's say you've got a nice big, north-facing roof, all is hunky-dory, but you've got a tree that causes a little bit of shade on your panels. Will one panel being shaded impact that whole array? Look, we used to think that was the case, and we used to put a lot of microinverters and have all these optimizers to try and get the panels to work independently. Honestly, these days, that's a waste of money. Panels today are often split up into 3 or 4 sections. So what happens if you get a bit of shade on one part of the panel is it'll actually drop off a whole third or 2/3 of that panel so the remaining panels can continue to operate. While the panels can get around the shade a lot more effectively than what they used to, especially with modern inverters, you still want to avoid the shade as much as possible because having a panel that's partly shaded puts the panel under a lot of stress. It's not only just the heat difference between the part that's in shade and part that's in sun, but the part of the panel that's in sun is pushing energy into those shaded cells, and they're heating up. You can almost think about them as like reverse LEDs, and they're just the energy is being dumped as heat, and this can cook those cells. So, a little bit of shade very early in the morning or very late in the afternoon when there's not a lot of sunlight, that's okay. But especially if it's in the middle of the day when there's lots of intense sunlight, you don't want any shade on your panels, no matter what the manufacturer says when it comes to how shade tolerant they are. You might see a very small variance between back contact and, things like bird poo, but at the end of the day, in real world condition, there's not a lot of difference between the two technologies. Another very common question I get is how they handle hail. Now, in Queensland especially, hailstorms are pretty common, and look, I even got hit by one myself. I had tennis ball-sized hail. The reality is most panels, or almost all panels today, they use tempered glass fascias. So they've got a pretty impact-resistant glass layer, a little bit like what you have in, say, a shower screen door. They can take a lot of punishment before they shatter. Now, anything less than a golf ball, you're generally good. So most panels today are rated from around about 35 millimeters hail. You might see some that are rated at 40 millimeters, but usually there's not that much difference between manufacturers because you can't make the glass too thick because then you're blocking sunlight through the glass, but also it makes the panels very heavy. So generally it's a bit of a balancing act. But anything less than a golf ball, you're probably fine. Anything much larger than, say, a mandarin or a tennis ball, well, then the hail is going to go straight through that panel, and that's what we have insurance for. So it's always good to let your insurance company know that you've got panels. It's usually covered under insurance already, but as part of a fixture of the house. But at the end of the day, it's always good to have it in writing. Another very common question I get is actually, how do we get the panels up on the roof? Now, if it's a low-set house, let's say it's single story, we can usually have a guy sitting on the ground and we can pass one panel up to the guy up on the roof. And that's pretty easy, but the panels weigh about 24, 26 kilos and, we can lift that up. Now, if it's a multi-story house, let's say we've got a lower level and then a higher level, we can often do what we call a two-stage lift where we go from the ground to the first level and then we have another guy pass it from the first level to the upper level. But if it's a multi-story house, let's say it's full 2 stories, we might use a panel lifter, which is like a lift for the panels. That means that we can safely get the panels up on the roof without having to walk them up a ladder, which is how these used to be done. But that is unfortunately not a very safe way to handle panels. If it's a 3 or more story building, then we will always say a commercial, like a factory building, then we will use a scissor lift instead, which is another way we can get up a bit higher and we can safely access that roof with the panels and get all our gear up there. So physically getting the panels up on the roof is only a small part of a solar installation. Keeping the panels up there permanently, especially in a cyclone, is a much bigger part of the job. So to do that, we use a racking system, and I've got some examples of racking on the table here. But there's sort of 3 parts that make up a racking system. We've got the foot, which is what attaches to the house. We've got the rail, which is what the panels sit on. And we've got the clamps that clamp the panel to the roof. And we have different feet depending on the different type of roof that you've got. The most common roof that we have for domestic homes would be a tile roof, for example. And so for a tile roof, we use a tile hook, which looks a little bit like an S. And how this works is we have a section or the base, which bolts to the truss or the rafter, which is the framing of the house. We then have this hook section, which slips in between the tiles. So we have the lower tile, and then the upper tile slides over the top. And this allows us to get from inside the roof through and out. So we have a section where we can attach the rail for the panels to sit on. A very common roof we have in Australia is a corrugated iron roof. Now, a corrugated iron roof is essentially a wavy piece of sheet metal. And it's sort of the classic Australian roofing material. Now, for a corrugated iron roof, we use a bracket a little bit like this, which are nice and curved to match the shape of the corrugated iron, or we like to call it a tin roof, even though it is iron, not tin, the metal. Now, you might see on a corrugated iron roof that these are curved to match the shape of the tin, but also they've got a layer of rubber to separate the steel from the aluminium. This is to stop galvanic corrosion. This is really important because we don't want the aluminium and the steel roof touching, causing the roofing material or the bracket to rust. Now, how these are installed is fairly simple. On a corrugated iron roof, or pretty much any steel roof really, you've got roofing screws that hold the sheet metal into the frame. So what we do is we take the existing screw out of the screw line, we go through the same hole with a bigger roofing screw, something that looks a little bit like this. It's got a nice big rubber washer on it, again to stop this steel screw from touching the aluminium bracket, and that goes through the bracket, through the sheet metal into the roof, and we're reusing the same holes. So we're not putting holes all through your roof. Sort of the third, maybe the least common roof that we have in Australia, but we do find this occasionally on very flat roofs, is what we call a Klip-Lok roof. And a Klip-Lok roof is an interlocking sheet metal where there's no screws going through the sheet metal to hold it onto the roof, but it's got a clip in underneath, and the roof sheets have an interlocking shape, a little bit like a triangle. They look a bit like an arrow, and they interlock when they clip together. And so we can't take a screw out and put it back in and, without putting holes all through the roof. But there's also, it wouldn't be the best way to do it. So what we do on a Klip-Lok roof is we use a clamping style system that physically clamps around that shape. And so there's a few different types of Klip-Lok profiles. So we have different profiles depending on the type of Klip-Lok roof you've got. So when you get asked, when you're getting quotes, what kind of roof you've got, it's good to know. Do you have a tile roof? Do you have a corrugated iron roof or a tin roof? Or do you have a Klip-Lok roof? There's other roofing roofs that you might see around, like Dechromastic, which is like a pressed tin. This would be highly recommended against installing solar on, because the only way to install on that is to drill directly through that tin, which is a really high likelihood of causing a leak. So if you do have a Dechromastic style roof, I'm really sorry, but we wouldn't recommend solar for a roof like that. Terracotta roofs are generally okay. We don't in-house install on terracotta anymore. They are very fragile, but there are solar installers out there that will install on terracotta, and they use a similar tile hook like you would for a standard concrete tile. So when we talk about screwing the foot through the sheet metal into the frame of the house, we're relying on the battens that hold the sheet metal to that wooden or steel frame of your house. But what if you have an older home where it's hardwood and the batten spacing is really wide? Most modern homes have lots of screws on them. There's lots of screws holding in that sheet metal, but older homes, especially old Queenslanders, might have really large spacing between the screw lines that may not work very well, because panels have clamping zones. There's a section in that panel where we need to clamp it, and this is engineered as part of that panel design. And there's a section here where the manufacturer of that panel says we can install these clamps to physically clamp the panel to that racking system. So if we can't put the rail in the right spot because the batten or the screw lines aren't in the right location, well, what we can do then is our last resort and use a direct to sheeting foot. And this system here, essentially, instead of screwing into the frame of the house, we screw it into the sheet metal and we bite into the sheet metal, and that's what's making up that structure that we're attaching to. And we tend to use these as a last resort, mostly because, yes, they will punch holes all through your roof, which we really don't want to do, especially if you have to remove the system later. You wouldn't want to have to also replace the entire roof. But the other thing as well is it tends to add a fair bit of cost and labor. So we do try to avoid these direct-to-sheet attachment systems where possible. But sometimes they're unavoidable, or sometimes it's the only way to get the size system you want up there. Now, solar systems or PV arrays will tend to last for 20 to 25 years, assuming you don't have a major hailstorm. And so they should last as long as your roof. And if you did have a severe weather event where you had smashed panels or a dented roof, usually they were replacing the sheeting at the same time anyway. So it's not the end of the world if you have a direct-to-sheet attachment system, but they're best avoided where possible. Now, if you have a really flat roof, you might have heard that it's good to have panels tilted. And a common question I get is, do I need to tilt my panels? If your roof is anything sort of beyond 5 to 10 degrees, there's enough of a slope on that roof for the water to run off the lip of the panel, because there's a frame that there's a frame around that glass that creates a bit of a lip, especially on that bottom side where dirt can build up. So we want to avoid the panels getting too dirty. Otherwise, you'll be cleaning them all the time. But if the roof is really flat, well, then you might want to lift the panels up enough just so the water can run off, or you might want to face the panels a little bit more towards the sun. Now, this is not to say that if you have an east-west facing roof, you should tilt those panels up so they face north. That is a terrible way to install a solar system. Not only can't you put as many panels on the roof, but it looks terrible and it acts as a giant sail. But if it's, say, you did have a flat roof, you got lots of space and you wanted to get a bit more efficiency out of that roof, or you wanted to make sure the water could run off and keep those panels clean, you can use a tilt frame system. So this is a way of building a structure that's got a nice angle on the roof, allowing the panels to face towards the sun and also that water to run off. There's not that much of an efficiency gain going from flat to 30 degrees north facing. So I normally wouldn't recommend tilt frames unless you had lots of roof space and you really wanted to get every last watt out of the array. Generally speaking, it's better to load up the roof with a few extra panels. Again, to gain 10% going from flat to 30 degrees is just really not worth it most of the time. But it is worth it to tilt the panels a bit so the water can run off, but you don't need that much of a pitch. So one solution that we have is a 5-degree bracket, where you have a lower bracket on one side of the panel, say down the roof, and then you have a taller bracket on the upper edge of the roof, and this increases the roof pitch, say from 5 degrees to 10 degrees. And this is a great way of just adding a little bit of extra pitch so the panels stay cleaner for longer. So once we've got the panels mounted to the roof, we also need to connect them all together to make that circuit and run the cables into the roof. And so behind the panel, we have cables that come out and they've got these plugs on them called MC4s, which is the modern way we connect panels. And so there's a positive and negative side and these connect together. And so the panels are wired in positive, negative, a little bit like fairy lights. That's for a standard string inverter setup. In the last video, we talked about the difference between string inverters and microinverters. Now, once we connect all the panels together in series, so we have all the panels wired in, now we've got to get the cables from the roof down to the inverter. And we're not going to just run the cables over the top of the gutter. That would be an awful way to do it. It's much better to run it into the roof and through the roof cavity, and maybe even internally down the wall where it's possible to do so. So if you've got a corrugated iron roof or a standard tin roof, often what's used are these things called deck tights. They're like little traffic cone looking pieces that you can curve them to match the shape of the corrugated iron, and then we can pass the cables through this rubber gland, which creates this nice seal. And then we can screw them into place so that the silicon will hold and it will create this permanent watertight seal. And this is done under the panel to keep them out of the weather. We'll put up some photos of examples of how this is done, but that's a very common way installing on a corrugated iron roof. But you wouldn't want to use these on tile because there's no way to screw these into the tile to hold them in place. And silicon, unfortunately, is a great gasket, but it's an awful glue, and eventually that'll lift. So for a tile roof, we use something that's a little bit more clever. So what we do is, this is the only time you're going to drill a hole through a tile roof, is we'll use a diamond hole saw, slip this threaded gland in, and then as we tighten it, it clamps the tile from both sides. And this allows us to create a permanent watertight pass-through into the roof. From there, we would run the cables through the roof cavity, down the wall, all the way to the inverter. So that wraps up part 2 of this Back to Basics mini-series, where we've spoken about panels and how they're installed. If you like this type of content, leave a like on the video so we can really show Mark that you want more of this type of content. Now, I know I haven't been able to answer all your questions, and there's no silly questions, so leave a comment down below and I'll do my best to answer them. Now, in the next episode, we're going to talk about batteries and how to get the most out of your excess solar generation.